So exercise 100, question number 1, um, using sine and cosine rule to find distances. If we draw out the problem again, that's the way forward. So what I've done here is to draw my north and west and east, and then put on the directions of these vessels. So one is going 32 degrees north of west, 45 kilometers per hour. So that's this one here, 32 degrees north of west. And the other vessel is going 35 kilometers per hour, 15 degrees east of north. So that's shown on this diagram. Then I've actually just transferred that information to a normal triangle. We can work out what this missing angle is here from the information we have there, and we end up with an angle of 73 degrees. We're after the distance travelled after 4 hours, so if we're going with a speed of 44 kilometers per hour for 4 hours, then the distance travelled will be that. So these two sides are given, and then we need to find out side. Let's call it side A, so we can use the cosine rule. Why do we need to use the cosine rule? Because we know none of the ratios. We know one angle, but we don't know the side opposite. In fact, that's what we're after. We know these two sides, but we don't know the angles, so we can't use the sine rule. So we're going to use the cosine rule. The missing side squared equals b squared plus c squared, the other two sides, minus 2bc cos of the angle. So I know the other two sides and I know the angle A, so I can plug those values into the formula. It might be worth remembering that A is the square root of that, of course, so in your calculator you can, to make sure you don't forget, put A equal to the square root of b squared plus c squared minus 2bc cos A. So then putting in the figures, we get A equals the square root of whatever these values are, 25 times 4 all squared, so 45 times 4 all squared, 180 squared, plus 35 times 4 is 140 squared, minus 2 times 45 times 35 times cos 73. And again, you can do that in one hit on the calculator. I recommend that you do that.